Okay, the SI base quantities. The SI system is an internationally agreed system of units, measurements as well. And we've agreed that there are 7 base quantities. They are as follows. They are the kilogram, the unit of mass, is the unit of length, which is measured in meters, the unit of time, which is measured in seconds, the unit of current, which is measured in amps, the unit of temperature, which is measured in Kelvin, the unit of the amount of substance, which is the mole or mole, and the unit of light brightness, which is the candela. Okay, the candela. Now, you don't need to know this one for the A level, but you certainly need to know these here. And all the other units that you know can actually be expressed with these units instead. Okay, and those are called derived units. So these are the base units, and then other units such as joule, watt, ohm are all derived units. Okay, so which of the following is not an SI base quantity, right? Well, mass is an SI base quantity, so that is the wrong answer. Length is an SI quantity, so that is the wrong answer. Charge is not an SI base quantity. You can see that charge is not there, so that is the right answer. And the final question is that time is also a derived unit. There we go, the time in measured in seconds. So the correct answer is C. Right, work is force times distance. You need to show that work can be expressed or written in the base unit. So you know that work is basically the same as energy. And energy, as you know, the unit of energy is the joule, which has the symbol J. Okay. Now, the way we work out the energy is by doing energy is given by force multiplied by distance. You just need to know these things, guys. Force, of course, is MA. The distance is measured, and so I can replace F with MA and end up with MAD or MAD. So energy or work is given by MAD. What's the unit of mass? It's the kilogram. The unit of acceleration is meter per second squared. And the unit of distance is the meter. So if we now put these together, you end up with kilograms. You've got 2 meters, so that's meters squared. You simply add up the indices, these things at the top, or the powers, and S minus 2 is the final one. So we're looking for that answer there, which is here. Brilliant, there we go. So that's the right answer, answer D. Right, number 3, link the derived units on the right with the more familiar ones on the left. Okay, let's try the volt first of all. Okay, let's try the volt. Right, the volt is defined as 1 joule per coulomb. Okay, it's 1 joule per coulomb, or JC minus 1. Now, neither of those are base units, but we do know that it's therefore going to be E over Q is how you work out the volt. Well, E, as we just worked out a minute ago, is given by force times distance. Charge, of course, you may know that Q equals IT, the unit, which is the current multiplied by time. I remember it as quit. Q equals IT. E equals force times distance. Again, force times distance should be written down as, well, force is mass times acceleration, ma, then multiplied by the d, the distance. And it, the unit of current, is amps. The unit of time is seconds. Okay, so let's keep going a little bit further. The mass is measured in kilograms. Acceleration is measured in meters per second squared, ms minus 2, and the unit distance is meters. We've already said the unit of current is A, but because it's underneath the line, it means it's dividing it. So you need to write it down as A minus 1. That tells us that the amps were underneath the line. And the same goes for the seconds. That should be minus 1. Now, if you notice, we've got 2 loads of seconds there and 2 loads of masses here as well. So we need to simplify this. So we've got 1 kg, we've got 2 meters, so that's m squared. We've got S minus 2 and S minus 1, so that makes it S minus 3, and then A minus 1. So this is the unit of voltage. That's what a volt looks like, which, if you notice, this is that answer there. So the volt goes to here. Cool. Let's look at the watt. Well, the watt can be defined. There's several ways of defining the watt, which is power equals voltage times current, and it also equals work done divided by time. And we've got to think as to which the one we want to use here. Work done divided by time. And as it turns out, this one's quite easy to do because we've just worked out the volt. We know that the volt is kg m2 s minus 3 multiplied by a minus 1. We know that's a volt. And then we need to multiply it by current again, times A. This time it's to the power 1. And if you notice, the A minus 1, the 1, they just cancel each other out. So what you're left with, the unit of power, is kg m2 s minus 3, which is that one there. So the watt goes here, watt goes there, which means then, therefore, that the ohm must go up here. Show that impulse, which is equal to force times time, and momentum, which is mass times velocity, have the same units. Okay, so we know that force times time, we've been told, is the same as a mass times velocity. If they've got the same units, they must be equal to each other. We've said that force is mass times acceleration multiplied by time, and that must equal mass times velocity. Right, the unit of mass is kilograms, the unit of acceleration is meters per second squared, the unit of time is seconds, and that will equal the kilogram, the unit of velocity is meters per second, there we go, ms minus 1. And if you notice, the s minus 2 will cancel this s1, so we end up with kg ms minus 1, and of course it equals kg ms minus 1. We have proven it. We have shown it to be the case. QED, which I think quod erat demonstrandum, that's what QED stands for. It means I have shown it to be, I believe. Okay, so that's your proof. Up here we end up with M2, S minus 2, and then we need to move what's on the bottom here upwards. So that will therefore make the M, and sorry, ignore that equals, that'll make it M minus 1, and the S will become positive when it moves to the top, so S2. So if you notice, that cancels that, and the minus 1 will cancel one of the 2 here, so we end up with meters equaling meters. Well, that's reassuring. So again, once again, we have shown it to be true. Right, let's have a look at this one here. So resistance R of a wire, read it by yourself. Okay, so what we need to do is to show that the ohm meter is a right unit of resistivity. So we need to say that ohm meter, which equals resistivity, must equal RA over L. Okay, well, this should be fairly straightforward, I guess. Right, well, what's the unit of resistance? Well, the unit of resistance is the ohm, the unit of area is meters squared, and the unit of length is meters. And of course, if you simplify this further, you end up with ohm meters squared m minus 1. If you add up the indices, you end up with ohm meters, which is what we had to prove, basically. Okay, so again, that would be a QED. You've shown it to be true. Right, express ohm meters in terms of base units. So we need to change ohm meters into, you know, the kg, mn, ms, all that sort of stuff. So what is the ohm then? Well, if we know the ohm is R equals V over I, that's how we define the ohm, voltage over current. And we know that voltage is basically, this bit here is E over Q. So that's going to be, I'm just looking at the top for now. The bottom's quite easy because that's just the amp. That'll be easy to work out. That's no problem at all. So we know the amp's at the bottom. The top is E over Q, and energy is force times distance times distance. So I'll do this across here so it's a bit clearer. E over Q is going to be the same as writing down energy is force times distance, and Q equals IT, that's charge is current times time. And of course we said before that F equals MA, so we've got MAD. The current is IT. And mass is measured in kilograms, acceleration is measured in meters per second squared. The current is measured in amps, so because it's divided, it's A minus 1. And the time, T is measured in seconds, so that's S minus 1 as well. I'll just shove this all up here just to so we know where we're going. Okay, I've run out of space, unfortunately. So that is the going back to R equals V over I, we've just worked out that V is kg m2 s minus 3 a minus 1. And if you notice, we now need to divide this by an amp as well. So you're going to end up with it being a minus 1 there again. So I can get rid of that. And then when I simplify that down, I end up with kg m2 s minus 3 a minus 2. And that's your answer for ohm meters. Cool. Well, that's it. I hope you find that useful. See you later. I'll leave you to read this yourself. Well, what we need to know is, let's make sure, is that basically we need to show that the unit of resistivity is the ohm meter. Okay, so the resistivity has got the unit, let's see, has got the unit of ohm meter. We need to say that that is correct. Well, the formula for resistivity is Ra over L. That is ohms multiplied by meters squared, then divided by meters, so that's going to be m minus 1. So now you're therefore left with ohm meters, because the minus 1 takes away that there. And if you notice, we've proven it by doing showing that. So that again is another QED. Right, let's get rid of these sketches first of all. So I'll go to screen, erase the pen. Right, the next one here is we need to show what ohm meters are in base units. Okay, in other words, the kilogram meters, second, and stuff like that. Right. So we know that R is V over I. So we're going to look at this one here. We're going to look at that one there. We know that that is V over I, so I could do that, V over I. I'm going to find out what V equals. Well, V is E over Q, which is energy over charge. That's going to be equal to, energy is given by force times distance. That's how you work out energy. And that will equal mass times acceleration, which is F equals ma, multiplied by distance. The bottom half, Q equals IT. That's the formula for the charge, is IT. And I can just put that across here as well. Now, if we now substitute the units in there, the unit of mass is kilograms. The unit of acceleration is ms minus 2. The unit of distance is meter. And then we have got divided by current, so that'd be A minus 1. When we put it up here, it's A minus 1. And then time S minus 1. Again, remember, this is the reason that these are negative is because they're under the line. So if we simplify that, we now end up with V. The V is going to be kg m. Let's look at all the m's. We've got 1 m there, 2 m's there. So that's going to be m2. And then we've got the 3's. We've got 1, 2, 3, s minus 3. And then we've got a minus 1. So that's the volts. And then in order to find out, we said the ohm is voltage divided by current. So this again is measured in amps. So we need to divide this by amps, which should have the effect of putting another A minus 1 there. So now we end up that the ohm is basically kg m2 s minus 3 a minus 2. But we need to know what the ohm meter is. So if we do ohm meters, it means we've multiplied that side by meters, so we must do the same to this side. So we end up with kg m3 s minus 3 a minus 2, and those are the base units. That's ohm meters expressed in base units.